This is going to go and remind us about what we were doing yesterday and making sure that we remember the exact order that we need to do everything in and the steps that I'm looking for you to show here as we go. Because both of those are going to be important going forward in order for you to actually be successful continuing to do these types of problems. So, first thing we want to do is get rid of any addition or subtraction. In this case, that means moving the x's, or in this case x squareds, to one side and the numbers to the other side. Now I'm going to go ahead and start by putting the x squareds together. And in order to do that, I like moving this x squared from the left to the right. And since it's a positive x squared, I'm subtracting it in order to be able to move it. Now you don't have to do it in this particular order. You could have done a few different things first instead, but it's the most common one. When we do that, we end up with 10 equals 2x squared minus 40. Having done that, my next step really is prescribed for me. I have to now get rid of the minus 40, moving it to the other side. In order to get rid of the minus 40, I'm going to add 40 to both sides. So we now have 50 equals 2x squared. Now in your work, I said that you could have done it in a different order. That's very true. But whichever way you did it, you would either have 50 equals 2x squared, or you might have had negative 2x squared equals negative 50. You will have one of those on your paper if you did this correctly. And both of them work. Alright, so I of course chose to do it on the left way there. So my next step now is I still am trying to get the x by itself, which means get rid of the multiplication now. So I'm going to be getting rid of that 2. Right now that's 2 times x squared, so I'm going to divide both sides by 2. Again, because I want to leave that x squared behind, and it's currently being multiplied, so I'm undoing what's currently there. So that gives me 25 equals x squared. Now this next step is the one that we learned yesterday, and most people got their head around pretty quickly, but not necessarily in terms of how do we show the work. So the next line of work that I want to see is where you're showing that you're taking the square root of both sides. So you write the square root over both sides that we have there, and when you do that, that is where you write in the plus or minus. I need to see it as soon as the square root is introduced.
I did that and you said it was wrong.
Then we can actually do the square root. So the square root of 25, of course, is 5, and that plus or minus just carries down in front of it. And the square root of x squared, well, this is the whole point of taking the square root, because it cancels out the squared. So we're left with the x on the right side. So x equals plus or minus 5, or you could also write that as 5 and negative 5 equals x. Those two mean the exact same thing. So whether you write it like this, or you write it like this, they're interchangeable. Now this is the next problem we're going to do. This one looks a little different from the ones we did yesterday, and so I'm going to be showing you an additional layer to the solving process. So please write down this problem so we can start working it through together along with all the work that's involved. So the first step in solving this is to get the part that's squared first. Before it was just x squared. In this case, it's getting the parentheses squared by itself first. So just like we did before, we're going to get rid of the addition subtraction. That means getting rid of the plus 3. So I'm going to go ahead and subtract 3 from both sides. In this particular problem, that is the only thing we can do first. There's nothing else we're actually allowed to do without it becoming a major, major mess. And I'm trying to give you these techniques so that you avoid those kinds of messes. Now that we're here, we are now to the part that is new and different from what we did yesterday. Because you notice that the outermost piece of this equation on the left-hand side there is the squared. So because that minus 5 is inside the parentheses, I actually need to get rid of the squared first. And of course, what do we do to get rid of squared?
Square root.
Square root. And so we now are going to take the square root of both sides. And so what I do is I just rewrite everything as it was before, except with square roots over both sides. And that one in front of the number, so in this case the square root is 16, that's where you put in your plus or minus.
plus minus square root.
All right, so now we go ahead and do that. And when we do that here, the square root, of course, cancels out the squared. So on the left side, we are left with x minus 5. And that is all that is left on the left side. It's just the x minus 5. So whatever was being squared is now left behind. Then, on the right side, we got that plus or minus square root of 16. The square root of 16 is 4, so that would be plus or minus 4.
Plus or minus 4.
It's both.
And remember, plus or minus 4 means 4 and negative 4. It represents two different numbers at the same time. And now that we have x minus 4 equals that, then to get the x by itself, of course, I just add the 5, right? But notice that something kind of weird and challenging happens here. Because if I just write plus 5 here, how am I going to do plus or minus 4 plus 5?
You add it and you do it.
It's kind of tricky because really what that should mean to us is we're going to do 4 plus 5 and we're going to do negative 4 plus 5. And that's kind of messy to talk about and show. So, new piece of information that we're doing today, because that equals 4 and negative 4, and we have one more step to do on it, I'm actually going to erase the plus or minus, and I'm actually going to write another equation next to it where it's equal to the negative. So I have one where it's x minus 5 equals 4, and one where it's x minus 5 equals negative 4. And now remember, I'm still doing the plus 5 to get the x by itself, but notice it now makes sense on the right side of both of those. Because for the first one, I end up with x equals 4 plus 5, which is 9. On the second one, I end up with x equals negative 4 plus 5, which is 1. So when we all of a sudden have the expression equal to the plus or minus, unless that plus or minus is your final answer, split it into two equations at that point.
Could you not?
That way you can keep operating on them. And in this case, because I did split it up, we wrote it as x equals 9 and x equals 1. But you could also write that as a single line. It's x equals 9 and 1. That means the exact same thing. Okay, so just again showing how it's connected, and it's really doing the same thing as we did before, just we had to kind of break apart the process so we didn't get mixed up with that plus or minus. All right, so for this problem, we're repeating the same process that we just did. So the first thing I want to do is get rid of the addition and subtraction. And again, be specific here, though. When I talk about get rid of the addition and subtraction, I cannot get rid of this one right now. It's trapped inside the parentheses. And as long as it's trapped inside the parentheses, I can't touch it. So that's why we only add the 12 to both sides. That's the only thing we can do first. So when I do that, I have 25 equals, parentheses, x plus 4 squared. Now, I got to get rid of the squared, because I still can't get rid of the 4, because it's still stuck inside of the parentheses. So I can get rid of the squared, which means taking the square root of both sides. And again, when you do that, we include the plus or minus in front of the number. So it's plus or minus root 25 equals the square root of the x plus 4 squared. And now we can actually take those square roots. So on the left side, that gives me a plus or minus 5. On the right side, that leaves me with x plus 4. Notice the parentheses are gone because the squared is gone. And all the parentheses we're doing before was telling us what was being squared. Now our next step, planning ahead, is I'm going to have to subtract the 4 from both sides.
Oh my God.
But you notice I all of a sudden now set it up where I would be doing plus or minus 5 minus 4, which to me is that red flag that says, wait, I need to break this up into 2. So I now go and I erase the plus or minus, so that's the positive side, and I set up the other equation with the minus. So I do minus 5 equals x plus 4. And I'm still going to be subtracting the 4, but now it actually makes sense what I'm subtracting it from. So notice how we know to use it. I ended up with plus or minus something, and I was trying to do something to it. All right, now we do the operation. So 5 minus 4 on the first one gives me 1. So there I got 1 equals x. On the second one, negative 5 minus 4 gives me a negative 9. So negative 9 equals x. Therefore, x equals 1 and negative 9. All right, so we started here by practicing what we did yesterday and kind of adding a layer to it with the number inside the parentheses. But Today is Friday, and Fridays like to make as a day to practice no calculator skills and be able to do this stuff without calculators. So this seems like a good day to bring in and remind us about how to multiply fractions. Today's work with fractions that we're doing is going to be focused entirely on multiplication. So today we're not adding, subtracting, or dividing with our fractions, we're only multiplying. And the reason why I like starting with multiplying is because it's actually the most intuitive of all the fraction work there is. Because in order to multiply fractions, you simply multiply straight across the top and multiply straight across the bottom to get your answer. This is the one fraction operation that happens very easily in the way that you might hope that it would. No special fancy rules. So on the top, what is 5 times 1? 5. On the bottom, what is 6 times 2?
8.
Who said 8? You're not adding.
And so our final answer for this problem literally is just 5/12. That's it. That's all there is to it.
Oh, you just multiply.
All right, so for this one, we're just going to multiply across the top, multiply across the bottom again. So you should have found that 2 times 4 on the top gave you 8. It'd help if that thing started writing correctly. There we go. And then on the bottom we do 3 times 15, which gives, or 3 times 5, which gives us 15. So we get 8/15. That's it. That is the multiplied fraction. That is our answer. So, again, we're multiplying these. So multiply straight across the top, straight across the bottom. On the top, 5 times 1 gives us 5. On the bottom, 2 times 3 gives me 6, so we end up with 5/6. A little side note here. Notice that in this problem, it was a top-heavy fraction, the 5/2. Did that change the way we handled it? No. We still did the exact same thing. All right. Now for this one, again, it's multiplying fractions, so it's the same process. Multiply across the top, multiply across the bottom. 3 times 9 gives me 27. On the bottom, both numbers are 4. Now, I threw this one in partly because there is a rule dealing with fractions where you have to have a common denominator and all that stuff. But that is adding and subtracting. That is not multiplying. So the fact that both of these are 4 changes nothing. So I still am going to do 4 times 4 and get 16. And again, we had a top-heavy fraction in the start. That didn't change anything. In our answer here, we have a top-heavy fraction. That's okay. Yeah, we could turn it into a mixed number, but I'm not worrying about that today. We aren't worrying about mixed numbers. We can go ahead and leave it as a top-heavy fraction for our final answer. All right, so in this question, we're told half of the questions on a test had negatives in them, a third of those questions had variables in them. What fraction of the test questions had negatives and variables in them? So all of a sudden we have a story problem, everybody's favorite. And in this story problem, there's stuff about fractions, there's stuff about negatives, there's stuff about variables. It looks like it could just be like one of the scariest things that some of you have ever encountered, because these are talking about the very things that you don't like in math. And yet this actually isn't so bad. Because the negatives and the variables, that's just talking about different types of questions. So we don't need to worry about like negative numbers or variables being involved in how we do this. What we do need to worry about, though, is the fractions that are given in here. We have a fraction of 1/2, because half of the questions had negatives in them. And we have a fraction of 1/3, because a third of the questions had variables in them. And when it asks what fraction of the test questions had negatives and variables in them, what does that tell me to do with the 1/2 and the 1/3?
Multiply.
We multiply them. Go figure. We did a lesson on multiplying fractions, and then you're going to multiply the fractions. Okay, so let's do the multiplication then. On the top then, what's 1 times 1?
1.
Oh, that was a tough one, right? Okay, what about on the bottom? 2 times 3?
6.
6. Okay, so 1/6 of the test questions had variables and negatives in them. That wasn't so bad. It looked scary. It was a word problem involving fractions and all this other stuff, yet it's not so bad. So just trust your techniques, trust what you have, and all of a sudden you'll find that with more of these problems than you probably think ahead of time, you actually can handle them just fine. So trust some of these things that we're doing and think you're going to be in good shape. And then there's one last problem we're going to do. This one I hadn't already put in the flip chart. So here is the original problem I'd like us to finish with. 2/3 times 5 please write down that problem and see if you remember how to solve it. If not, good news is we're going to be going through it here in just a moment. So the trick to this problem is the fact that 5 is actually a fraction. It doesn't look like a fraction though, does it? But that's because everything can actually be written as a fraction. Anything is a fraction. X can be written as a fraction as well. Anything can be written as a fraction simply by writing it over 1. And so 2/3 times 5 is the same as 2/3 times 5 over 1. Go ahead and now finish out that problem. All right, so now we go ahead and do that multiplication. Multiply straight across the top. 2 times 5 gives me 10. Multiply straight across the bottom. 3 times 1 gives me 3. And we get 10/3. And then once again, yes, I'm okay with you just leaving it as an improper fraction here, or a top-heavy fraction. Both those things mean the same thing. You do not have to turn it into a mixed number. Although if you really want to, feel free to give it a shot.